Okay, today we're going to talk about solving equations that include the step combining like terms. So in our TOC, we should have Unit 2, multi-step CBLT, and I'm on page 28 in my notes. The time before we wound up using 2 pages, 26, 27, so now we're on page 28. Okay, so just a refresher, combining like terms. In order to combine like terms, they either have to both be fixed numbers or they have to have the same identical variable or variables with the same exact exponent. So when we think about identical variables, x plus 2x, these are the exact same thing. Our bases are x, their exponents are 1. That would give me 3 x's. X plus 2x squared, these are not the same. This is an x to the first power, this is an x to the second power, not the same. Xy plus xy, exactly the same. 2 xy's is what I have. So please keep that in mind when we're thinking about combining like terms. So our example problems for this include, number 1, 12x plus 14 plus 10x equals 80. I'm gonna just lower the screen a little bit over here so you can not blinded by the light like I am now. That's a little bit better. So when we're going through this, what I like to do is I like to use shapes or colors to help me distinguish what's alike and what's not. And I usually start on the right side and work my way left up to the equal sign. Because when we talk about combining like terms, this occurs on the same side of the equal sign. So I'm going to look on the left side and see if I have anything to combine. I'm going to do that. Then I'll look at the right side and see if I have anything to combine there. So here on the left side, I have a 12x and I have a 10x. And those two things, they both have x to the first power. So 12 plus 10 is 22 and x. 14 is a fixed number. There's no other fixed numbers, so that's simply going to come down. So 22x plus 14. And on the other side, I only have one term, 80. So there's going to be no combination over there. So I've just completed the combining like term step or the combine step. Remember our 5 steps: distribute, combine, rewind, solve, and check. We didn't have any distribution because there's no parentheses. We did have combination because we have similar or like terms on the same side of the equal sign. We just executed that step. Now we're going to rewind. When we rewind, we work backwards through the order of operations, our goal being to get whatever variable we have by itself on one side of the equal sign. So right now, looking at this, I need to undo addition or subtraction, also known as positive or negative fixed numbers. So I'm going to undo positive 14. It's additive inverse, negative 14. I do that to both sides of the equation. And when you show us your work, this is what we want to see. We want to see it written on both sides, not one side, both sides. I didn't do anything to the 22x. These are additive inverses, so they create the identity 0, which is, we don't need to write that down. And 80 minus 14. 80 minus 10 is 70. 70 minus 4 is 66. Then I'm going to undo 22 times x. I'm going to use the multiplicative inverse of 1 over 22. This has the same effect as dividing by 22. And I'm left with x over 66 divided by 22. And that simplifies to be 3. So here we did the combining like terms step. We did a rewind step here, a rewind step here. This was our solve steps. And now if I do my check, if I put 3 back in, 12 times 3 plus 14 plus 10 times 3 equals 80. So 36 plus 14 plus 30 should equal 80. 3, 4, that's another 10, so that's 5. 5 plus 3 is 8, so 80 equals 80. True story. I know that I've completed it correctly. Our second example, we have 6c minus 8 minus 2c equals negative 6. Again, any grouping symbols? No, so I'm going to skip the distribute step. Combine like terms, let's look at this side, 6c, negative 8, negative 2c. 6c and negative 2c are alike. 6 minus 2 is 4. With the c, negative 8 is our fixed number, equals negative 6. So this was CBLT, combining like terms. Now I'm going to do a rewind step. My ultimate goal is to solve for c, which means I isolate the term for c first. The opposite of a negative 8 is a positive 8. I put that on both sides following that golden rule. That eliminates to be 0. So I have 4c equals negative 6 plus 8, positive 2. I had $8, I spent 6, I only have 2 left in my pocket. I'm going to multiply both sides by the multiplicative inverse to get rid of the 4. And you'll see here why we like to do that. Okay? 4 doesn't go into 2 evenly, right? 2 is a smaller number than 4. So when I combine that fraction, I wind up with 2/4. My answer is 1/2. Now, be cautious. If you tell us the answer is 0.5, we're going to mark it wrong. Unless we ask for a decimal, unless it's contextually appropriate to the problem, like we're asking about money, or if the problem started with a decimal, then you can give us a decimal. Otherwise, it better be a fraction. Fraction. We're going to get you over your fractionovia yet. So that's our second example. And the final example for today is negative 3x plus 25 plus x plus 21 equals 2. So for step number 1, distribute. I don't have any grouping symbols, so I move on to step 2. Combine like terms. I look at the left side, I look at the right side. Right side, we can see we have one term over there. No combination is going to occur. Over here, I have negative 3x, positive 25, positive x, and positive 21. So negative 3x and positive x are alike. 25 and 21 are alike. And you'll notice that not only did I use different colors, kind of hard to discern because one was purple and one was blue, but I used different shapes. So I know that my two circles go together. Negative 3x and positive 1x are going to give me negative 2x. And my two squares, 25 plus 21, is going to give me 46. You'll notice I seamlessly use the integer rules there. And that's what's expected when you solve equations. Again, I now move to my rewind. So I was at CBLT. So that was combined. Now I move to a rewind step. Ultimately, I need to solve for x, which means I isolate this term. So the opposite of a positive 46, negative 46 to both sides of your equal sign. By the way, if you need to draw what's known as, some people like to call it the river, you draw a little river right in here so that they know where that equal sign is. You're more than welcome to do so. So negative 2x, I didn't do anything to you. 46 and negative 46 are additive inverses that simplify out to be 0. And 2 minus 46 is negative 44. Still rewinding, I'm going to undo the multiplication between negative 2 and x. Yes, negative 2 and x, not 2 and x, negative 2 and x. Remember, my ultimate goal is to find out what the value of 1x is, not negative 1x, positive 1x. So I'm going to multiply both sides by its reciprocal, also known as the multiplicative inverse. So negative 2, multiplicative inverse is negative 1/2. You'll notice that an inverse does not change the sign. We're not talking about an opposite number. We're talking about an inverse number, right? We want the multiplicative inverse, which means flip your number over the fraction bar, not change the sign. So here, this is going to eliminate to be the multiplicative identity of 1. So we're left with 1x. Negative 44 over negative 1/2. A negative times a negative is a positive. 44 times 1, 44. If I pretend that's a fraction, 1 times 2 is 2. And if I simplify that, 2 goes into 4 twice, and I have 2 4s, so x equals 44. Now, in these last two, we didn't do the check portion of it. That is something you should be doing. You can execute that in your head if need be, but you should be checking to make sure your work is correct. And that is your lesson for today, incorporating combining like terms or performing the combine step out of our 5 steps for solving equations. Distribute, combine, rewind, solve, and check.